can't be 0? The denominator. The bottom of the fraction can't be 0. Okay. So we tried to rewrite this without a fraction, but we had to pay close attention. If I look at the beginning, what can x not be on this problem? 1. So I just make myself a note. All right, so then we have to multiply. If you want to get rid of the fraction in the first one, what do you multiply by? So if you multiply one of them, every single term gets a 2, because you would have to distribute it to both sides of the equation. What else do we have to multiply by? So every single one gets an x minus 1. So in the first fraction, the 2's drop. Second one, the x minus 1's drop. So we're left with 2x minus 3 times x minus 1. Second one, we have 2x times the 2. The last one, I have x times all this. I'll go ahead and distribute. So x times 2x minus 2. So if we multiply this all out, you FOIL these, and I already put what you got there. Plus 4x equals the 2x squared minus 2x. When we start combining, let's just combine like terms over here. So negative 5x and positive 4x is negative 1x. If I subtract over my 2x squared, what happens? Those cancel. I'm going to add over this x. So I get 3 equals negative x, so x has to be negative 3. Sorry, we used one more line than I left for you. Is that answer okay? Yeah. As far as checking, you should be paying attention on all of these. You can always grab a calculator, plug it in. The big thing here is that the denominator doesn't equal 0. So it doesn't, so negative 3 is my only answer. Alright, that was the first type of problem we did in this section. The second type was problems with radicals. And so our strategy was to isolate the radical and try to get rid of it. So for instance, if I gave you this problem, what would you do first? Add over the 2. Then what is the opposite of a cube root? Cube it, so we cube each side. So on the left, a cube root and a cube cancel and just leave us with the 2x minus 4. On the right, 2 to the third power equals 8. So if we add over our 4, we get 12, divide by 2, and we get 6. Make sure you are checking on these. These are the problems where it may not work. You don't really have to show me the work, but make sure you're doing it. If we plug in a 6, 12 minus 4 is 8. Cube root of 8 is 2, minus 2 equals 0, so it does work. What if it didn't work? What would we say? No solution. All right, the third type. There are different ways of solving it. I had already made this paper, but I think when we, in class Friday, we really didn't do a whole lot of substitution. You guys were kind of comfortable with just factoring things as is. And so we kind of did it that way. So we have two options. I have this one set up to do substitution. I'm going to show you how to do that, and then I'll show you another way you could work this problem. And you pick what you like, okay? So when I look at this problem, I see it's kind of like a quadratic. I have something squared, the same thing to the first, and a constant. We did one like this Friday, and the suggestion that you guys gave me was just to multiply it out, so I did. And did that work? Yeah, we solved it. There are other ways. So one way is by doing a substitution. If you realize that both of them have this x plus 2, you can just plug something in for it, so maybe a u. So I'm going to replace my x plus 2 with just a u. So then x plus 2 squared is u squared. 11 times x plus 2, which I'm just changing to a u, minus 12. Why is this helpful? What can you do with that? Yeah, easy method. What multiplies to negative 12 and adds to positive 11? Thank you. Negative 1 and positive 12. So if we set those equal to 0, we get u to equal positive 1 and negative 12. But I'm not done. The original problem had x's. So I have to change this u back into the x plus 2. Okay, so if x plus 2 equals negative 12, subtract your 2 and x is negative 14. If x plus 2 equals 1, subtract your 2 and you get negative 1. And then we check it, which this one, if you plug them in, does work out. So we get those two answers. Now, could I still have chosen to multiply all this out at the beginning? Absolutely. Some people can even factor this without the u. If that's you, great. If it confuses you, don't do it. But some people look at this and say, well, I have an x plus 2 squared, so I have 2 of those. So if I set up my 2 parentheses, each one gets an x plus 2. What multiplies to negative 12 and adds to positive 11? That was positive 12 and negative 1. What's x plus 2 plus 12? That's our x plus 14. X plus 2 minus 1. So 2 minus 1 is 1. And you get the exact same answers. So there's at least 3 different methods for solving this one problem. I'm not going to tell you how you have to do it. I'm just going to say solve it. So whatever makes sense to you, use that method. Okay? What questions do you guys have for me?